All right. Good morning, everybody. How are we doing today?
This half is really great. This half, I can only assume is terrible, right, David?
Well, let's give them another shot.
Okay, that's fair.
Okay, so how are we all doing today?
Much better.
That's what we like to hear.
Yeah.
Well, as I just told most of you, although thank you to some of our new viewers here today, my name is David.
My name is Taylor.
And Taylor, we're going to talk about what today?
Today we are talking about liquid nitrogen!
All right, okay.
That's exciting.
Not too bad. Viewers at home, we can only assume that you're excited. But Taylor, maybe we need to bring everybody up to speed on what liquid nitrogen
That's
is.
a great idea. So who here's ever heard of liquid nitrogen? Oh, quite a few people. Okay, cool. Well, who here has ever experienced nitrogen?
Okay, and can I help them out?
Absolutely.
Okay, everybody take a deep breath. Exhale. And now raise your hand. Yeah, we all experience nitrogen around us all the time because what, 78% of that gas is nitrogen?
That's right, we breathe nitrogen every breath that we take. But that's different, right, David? That's
Yeah.
a gas. But we're talking about liquid nitrogen.
Well, that's just a difference in the state of matter.
Oh, so we should probably go over states of matter, right?
Yeah, let's do a quick review.
Good idea. So, okay, do you guys know your states of matter? Yes. Okay, cool. So an ice cube, what state of matter is that? Solid. Right, you take that solid, you add heat, it melts and becomes a liquid. You take that liquid, you add even more heat, it boils and becomes a gas. Now one more time, to go from a liquid to a gas, we have to make that liquid really hot. So what do you think we'd have to do to go from a gas to a liquid? We'd make that gas really cold. That's exactly right. Now, David, liquid nitrogen is very cold, right?
Yes, it is. Now, I wonder, I want to see if our viewers at home are actually paying attention. Somebody at home, post on our stream, what is the freezing point of water?
That's a great idea. And if you guys know it out here,
Will you let us know if somebody posted? Did somebody?
Not yet.
All right, guys, we're working here. They are shaking with excitement to tell us what that.
They all know the answer. So viewers at home,
you
have access to the internet, you guys.
You could Google
Do we
it.
have one?
0 degrees Celsius or 32 degrees Fahrenheit. Who was that viewer? John. Let's give a round of applause for John. Something tells me that that's our COO.
Is it John?
John, is that? No? Another John! All right. Thanks out there. That's not the last question today. So, who out there knew 32 degrees Fahrenheit was the freezing point of water?
That's impressive.
Excellent.
Okay.
Now, here's the question, and we'll work together in tandem with the people at home.
Great.
What is the temperature of liquid nitrogen? Anybody have a guess?
Should we get a few guesses from the audience?
Yeah, do that too,
Okay.
yeah.
Who has a guess of how cold liquid nitrogen is? What is your guess? What do you think? Super cold. That's true. That's true. Does anybody else have a guess? What do you think right here, sir?
Temperature?
You right here. What do you think? 10 degrees. What a good guess. What do you think? Negative 100.
We're getting closer.
Are people guessing online? There's a delay. That's okay. That's okay. They'll get up. What do you think? Negative 199. Oh my gosh. Anybody on this side? What do you think back there? Negative 200. One more back here. What do you think, sir? Negative 109. Okay, we've got some good guesses here.
We're on the right track.
We sure are.
It's a little bit colder, though.
That is true.
It's negative 320 degrees.
That's super cold. So because it is so cold, David, we have to be extra safe, right?
That's true.
So David and I have on our stylish long lab coats, long pants, closed-toed shoes.
Yeah.
We both have on goggles.
Yeah,
and
we do.
I'm going to join you in getting on our cryogenic gloves. Beautiful shade of blue. These are called cold. So we're super stylish for you guys today too, as well as really safe.
Thank you.
Liquid nitrogen is actually so cold that if we were to touch it, our skin would process it as heat and it would burn us.
Yeah, we would get frostbite. Anybody heard that term before?
Right.
Yeah, now to begin our experiments today, we need to start with a balloon.
Oh, party time, okay.
Now, Taylor and I like a little friendly competition.
We do, it's true.
So let's see who can inflate a balloon faster.
Sounds good to me, okay.
All right, now who out there thinks that I can inflate my balloon faster? Okay, 4 people, fantastic. Who thinks that Taylor can inflate her balloon? Audibly the crowd favorite.
That's okay.
All right, well let's put this to the test, shall we? Give us a nice countdown, people at home. Never mind, we'll get it here. Okay, here we go. In 3, 2, 1. Excellent try, Taylor. Just not quite fast enough for the likes of me. Thank you, Steve. I know.
He's just so full of hot air that of course his balloon will go faster.
Well, Taylor, will you do me a favor? Will you check on that balloon, make sure that it's okay?
Absolutely. Let me get some balloon experts out here over here. Do you tell me, is this balloon okay?
That's a beautiful blue balloon in great condition.
One more time, David.
That blue balloon is going to be good for our experiment?
Blue? Is this? It's what color?
Oh, I'm so sorry. This green balloon is going to be great.
Hang on.
What's that?
David, should I guess this?
Oh, this red balloon. I am so sorry.
It's okay.
That will be
It's
a
all
good
about
condition.
perspective.
Yeah, exactly. Now, Taylor, it seems okay?
It's great. We have our balloon expert that says it's good to go.
Wonderful. Well, we're going to introduce this balloon to some liquid nitrogen. And what do we think is going to happen?
Oh, David, it sounds like we're going to make a hypothesis.
Hypothesis. That's exactly right. An educated guess.
Right.
Now, let's get some hypotheses from the audience there.
Viewers at home, if you have a hypothesis, let us know. Let's get some guesses over here. All right. What do you think is going to happen to the balloon? Starts to deflate. A very good guess. What do you think, sir? It's going to get small. Really good. What do you think? Gonna freeze. What do you think? Shrink. What do you think? It's gonna freeze. Back there, nice and loud for me. All the air is gonna come out. Back there, what do you think? Ooh, good guess. Anybody over here have a guess? What do you think? Way back there. Nice and loud for me. It will blow up! Oh my goodness.
Oh.
Well, David, we have a very wide range of guesses here.
That's true.
I think we should put it to the test.
I think so, but Taylor, before we do, I have a question for you.
Sure thing.
Do you know what the scientist pirate sails on?
I don't, David. Tell me.
The hypotheses. Let's test this out, shall we, Taylor? Okay. Now we've all created our hypothesis.
We have.
We're ready to test this out. So I'm going to pour some liquid nitrogen over the balloon.
Excited.
Here we go.
Oh man, the balloon is losing air. That's okay. We have more balloons. We can do it again.
No, Taylor, the balloon itself is fine. It's the gas inside the balloon that we need to be worried about.
Well, what happened to it, David?
Well, think about how we go from a gas to a liquid. What do?
We make the gas really cold.
That's right. Right now, the negative 320-degree liquid nitrogen is condensing the gas inside the balloon, turning it into a liquid.
Okay, so all the molecules are getting really, really small and close together.
Exactly, and that state of matter changes.
Okay.
Now, just to prove...
David, will the balloon ever be normal again?
Yeah, stop being so dramatic, Taylor. The balloon is fine. So, all we have to do, take the balloon out of the liquid nitrogen and add heat.
What? David, that's so cool.
Oh, Taylor, very funny.
Thank you, David.
If you have any freezing puns at home, feel free to write them in, and we'd be happy to share them with our audience so they don't laugh either. Now, Taylor, moving on.
Sure.
We've talked about the effect that liquid nitrogen has on one gas.
Right.
What do you want to talk about in terms of other gases?
Okay, well, I have a really good one, but I have a question, you guys. It's a beautiful day outside, isn't it? There's not a cloud in the sky, is there? All right, so let's make a cloud inside here.
Yeah, let's ruin some days.
Let's ruin some days.
All right, so Taylor, how are we going to make a cloud this time?
Well, I just need some water, David. Do you know where I can find some water?
Yeah, from my water bottle here, I've only drank about 4/5 of it, so if you want to use what's left in there,
Well,
that's
that's
fine.
actually perfect because I need water, but I also need air.
Oh, that's
It's inside there.
right there, yep, on the top.
So clouds in the sky are made by water vapor getting really cold and condensing.
That's right.
Right, so by making the gas, the air and the water inside that jug really cold,
Yeah.
I can make a cloud.
Okay.
So I'm going to pour the liquid nitrogen inside of this jug.
Oh, and as soon as you do, it starts to condense.
Right.
We see the cloud form. We're going to add a little extra because we want a nice big cloud.
And with a little callus. And then
regular Christina Aguilera.
That's right.
Now, Taylor.
Yes, David.
This conversation, as you said, is a cloud, but this gives me an idea. And you might not know about this about me, Taylor, but I have been taking cooking classes.
Thank goodness. David, that's so good. I'm so proud of you.
Well, thank you, Taylor. I appreciate that. Well, and I'm specializing in liquid nitrogen treats.
Whoa, David. You're saying that we're not even safe to touch liquid nitrogen. How are we safe to eat liquid nitrogen?
Well, think about it this way. We cook with fire, but we wouldn't eat fire, right?
I guess that's true. You're right.
It's the same basic idea. So today, I'm going to make a treat called dragon's breath.
That sounds scary, David.
It is. Now, Taylor.
Yes.
Even though I've just said it was scary, we're going to need some volunteers today.
That's true. We probably need someone maybe 7 years old or older today, right?
Yeah, that would be much preferred.
All right. So let's see. Who's 7 years old or older and wants to try the liquid? Okay, let's.
And Taylor,
David, how many do you want?
Half a baker's dozen,
Sounds
please.
great. I'll have to cut someone in half. That's no problem. Will you come on down? I'm just kidding. You back there can come down. 1, 2. Yep. You can come down. 1, 2, 3. And you guys are gonna stand right against this line right here, okay? So right like this. Make sure you face the audience. 1, 2, 3, 4, 5, 6. David, I'm gonna do 7. 7. Come on down.
That's good.
Woo. Woo.
All right.
So you guys are gonna get in a line like this. Face a line this way. Perfect. So will you two come stand right over here for me? Will you come stand right over here?
I'll take a little big step forward if you don't mind, Taylor.
One step forward. Perfect. Now, if you know anybody in the audience right now, even at home, you'll want to get your cameras out because this is a great photo opportunity, okay? So, really quick, I'm going to give them the rules, okay, David?
That's great.
All right, so here's what's going to happen. David is going to put, while he's over there singing while he cooks, he's going to put a little piece of graham cracker in your hand. You're going to take that graham cracker, you're going to put it in your mouth. You're going to forget the rules about chewing that you learned, and you're going to start chewing with your mouth wide open, okay? So again, the process is graham cracker, pop it in your mouth, and chew, okay? Now again, this is a great photo opportunity, everybody.
Okay, y'all ready for this?
We're ready, David.
Okay, I'm going to get rid of the excess liquid nitrogen, and then will you show them how it's
Of
done?
course I will, David.
Okay.
All right, I'm going to take one.
Take one.
Graham cracker.
Pop it in your mouth and chew. Got it? Take one. Pop it in your mouth and chew. Take one. Take one. Pop it in your mouth and chew. Pop it in your mouth right away.
Keep chewing.
Take one. Pop it in your mouth and chew. Take one. Pop it in your mouth and chew it. Take one. Pop it in your mouth and chew. You got it. Pop it in your mouth and chew. And this, ladies and gentlemen, is Dragon's Breath. Give them a big round of applause. Can head on back to your seat. Yeah. What?
I said yummy, yummy.
Yummy, yummy. Yep, loving my tummy.
Absolutely.
Now, Taylor,
Yes,
we've talked an awful lot about the effect that negative 320 degrees of liquid nitrogen has on different objects.
Yeah, we have.
I would like to look at liquid nitrogen itself for a little while.
Oh, sounds good. Okay.
Now, before we get to our next experiment, this is a lovely opportunity because a lot of our staff that you don't see on the floor every day is here. So do you mind doing a quick panorama? If you're a member of the Michigan Science Center staff or volunteers, will you please stand up so that we can give you a big round of applause? Let's give them a round of applause, everybody. Excellent. Okay, don't sit down. Come on up here, everyone.
Come on down, staff.
Yeah, come on.
Just our staff members, okay?
Now,
Perfect.
on behalf of the Michigan Science Center staff, we do want to volunteer and take the opportunity to thank you all.
That's right.
Now, today, in order to understand our next experiment, we need to sing a little song and do a little dance.
Our vice president finds this very funny.
Oh, yeah. It's been nice working here. So now, we will need your help singing along today. We're all going to lead our audience in a rousing rendition of I'm a Little Teapot. Feel free to sing along at home if you'd like.
Let's sing along.
So here we go. Make sure to do the dance it's due. Ready? I'm a little teapot, short and stout. Here is my handle, here is my spout. When I get all steamed up, hear me shout. Tip me over and pour me out. Give them a big round of applause. Thank you all. Go on and have a seat.
Oh, man.
You are just wonderful, and it's been nice being your colleague.
Yeah, we know.
I'll turn in my keys at the end of the day.
Sounds good.
Now, we do this song to make you laugh, and
It does serve a good purpose.
yeah, there's a little detail in there, Taylor. When it gets all steamed up, we hear it.
Shout.
That's right. Now, it's not actually a shout. What's the noise that it makes? What do we call that?
A whistle.
A whistle. Now, Taylor, will you show them what that sounds like? Well, I mean, that was a great Snoopy impression.
A fun fact about me that David knows is that I cannot whistle.
No, that's true. Can anybody out there whistle?
Let's hear it.
Let's hear it.
Whoa, yeah.
Yeah, very good.
Got it.
Yeah. Now, we demonstrate this again so that you know what this tea kettle is going to do.
Okay, David.
Taylor, would you believe that when I pour liquid nitrogen into this tea kettle, it's going to start boiling?
Absolutely not, David. We are talking about liquid nitrogen, which is cold. We know that cold things don't boil, hot things boil, so there's no way that... Okay, well... You embarrassed both me and yourself.
Touche. Now, Taylor, you know what's going on here?
I have no idea, David.
Well, to boil something needs to go from a liquid to a gas. So right now, the liquid nitrogen in here, negative 320 degrees, is heating up just a little bit, and it immediately starts to boil, converting into a gas.
Oh, so to boil doesn't necessarily mean to get hot. It just means to get hotter.
Exactly.
Oh, okay.
Different objects, different things have different boiling points. Water, 212 degrees Fahrenheit. In this case, liquid nitrogen down there below zero.
Right, interesting. Okay.
Now-
that kind of gives me an idea a little bit.
Oh.
Okay. So we're talking about how it boils, right?
Yes,
And when it boils, it goes from a liquid to a gas.
that's true.
Now we know that gases fill up to fill the container.
Yes,
They
that's
take up more space than liquids do, right?
yeah, greater volume. Yeah.
Exactly. So let's go back over here for 1 second, David. If I hadn't let the gas come out of here,
Yes.
and I stopped the gas from escaping,
Yeah.
what would have built up inside me?
Pressure would build up inside here.
Pressure, because we're letting that gas go bigger and bigger, but not giving it any way to escape.
It would be. We should do that sometime.
Let's do that.
Back to the show.
Anyway.
So, pressure.
Pressure would build up. So
Yeah.
I can actually use that idea, steal a little bit from NASA, and I can launch a rocket using liquid nitrogen.
No
Is
way.
anyone interested in seeing that?
Who wants to see a rocket launch?
I'm not convinced, David.
All right.
I'm allowed, but not really.
Let's see. Who wants to see a rocket launch?
All right.
Anybody on the stream want to see it? Okay, good. Okay, we're just going to assume yes.
All
Fantastic.
right, sounds good. All right. Well,
Taylor.
Yes, David.
In order to launch a rocket, we need a rocket. So will you show us that
Are
rocket?
you guys ready to see the rocket?
Here we go.
All right, here it is.
Oh, that is disappointing. Taylor, that's a water bottle.
Oh, wait, okay, so it used to be a water bottle. Maybe I drank it for lunch today.
Yeah.
But now it is a bottle rocket.
Hey,
that
very
I
fun.
get to go to the ceiling, David.
What? All the way to the ceiling?
All the way to the ceiling. The ceiling's way up there. So look, there it is.
I know you guys can't see this at home, but the ceiling is 18 stories above us. And you believe you can get it all the way up there?
I do. Do you guys believe me?
All right, Taylor, so how are we going to make this happen?
Well, all I need, David, is just a little bit of liquid nitrogen. Now, I'm going to stand behind this shield for the sake
Okay.
We don't want to get the viewers at home wet.
That's true, that's true.
So I'm going to pour just a little bit of liquid nitrogen. Now again, the liquid nitrogen is going to get way bigger. It's expanding to fill the container that it's in.
Yeah, it expands at a ratio of about 1 milliliter to 700.
That's exactly right. So I need from you guys a good old-fashioned countdown.
All right, let's give a countdown in 5, 4, 3, 2, 1. Heads up. Well, me. Oh, here, I'll take that right here. Thank you. Now, that was pretty impressive.
They go to the ceiling?
For your feelings, we're going to say yes.
Did it?
It was like this close. It's all right. Next time. Next time. Now, Taylor, I have a question.
Sure.
If we had put this lid back on to the pop bottle,
Yeah.
what would have happened with the liquid nitrogen inside?
Well, that pressure would have kept building and building and building, and eventually would have had to blow up. Now, I don't know what you're thinking, but I don't want to blow that up because that's made of plastic.
Okay.
And that can be kind of dangerous.
Well, that's a good idea.
But I don't want to leave the viewers at home or our wonderful audience, I don't want to leave them without a big grand finale, David.
Okay, well, let's see if we have something else that we can... Thank you, Steve. Let's see if we have something else that we can explode.
We blow up this funnel.
I have a battery, glove, fake lettuce, pen, slinky. Hey, I got it. Let's blow up a balloon.
Oh, perfect.
Yeah.
So we don't have 99 red balloons.
How's that song go?
What's happening?
Alrighty. Now, we're going to take this balloon here and use a very similar process. Come on. We're going to put some liquid nitrogen into this test tube. Will you pass me the liquid nitrogen? Now, when we put it in here, this gives us a great opportunity to see that the liquid nitrogen is boiling.
That's right.
All right, fill that up.
You'll see it looks just like boiling water, right?
Exactly, but it's happening at room temperature.
Exactly.
And
Now,
liquid
David,
nitrogen-
I'm going to give the audience a quick warning about what's going to happen next.
That's a great idea.
So next, David's going to put a balloon on the test tube. Now, if you don't like the sound of a popping balloon, this will be a great opportunity for everybody to cover their ears, okay? So if you don't like the sound of a popping balloon, everybody will want to cover their ears. David's got his ear protection on.
What?
Nothing, David.
What?
We're good to go, David.
That?
Yep.
Oh, wait, safety gear.
Okay.
All right.
No, David, you have it. David, you already have this on. David, you have.
Okay, we ready to go?
We are very ready to go.
All right. So I'm going to put the balloon
David's covered.
over the test tube.
It's getting bigger. The pressure is building up. The gases are getting bigger. We're
There.
going to speed up the process a little bit by flipping it over. The gases are expanding. And any minute, we'll never know when. Any minute.
Way too much pressure for that tiny balloon to handle.
Well, David, you know what they say in show business, right?
Yep, never whistle in the theater.
Never heard that one before, but you know what else they say, David?
It's bad luck to say good luck on opening night.
They do say that too, but they also say...
Never say Macbeth.
You did.
Oh.
Well, but they also say that every good show should end with a bang.
And that was hard.
I think
Okay.
that was hard. So I think that does bring us to the end of our show today. Did you guys have fun?
Now, Taylor,
Yes.
even though this is the official end of our show, because you at home have been watching, do we have any questions people have asked? No questions.
Well, viewers at home, start asking your questions.
Anybody in our audience have questions? We can answer a few today. Yeah, what's your question? Why was your tongue so cold? So the question is about dragon's breath. Why is your tongue so cold? So when we cook with the liquid nitrogen, it actually lowers the temperature of the graham cracker. Sort of the opposite of what would happen if you put a marshmallow over the fire. So when you put it into your mouth, your tongue gets really cold. It's kind of like eating really cold ice cream. It's the same basic idea, but made in the moment. Any other questions? Yeah, way back there in the back. Oh, the balloon deflate. Yep. So in the beginning, when we poured the liquid nitrogen over the balloon, the gases cooled down, and the molecules got really close together, and it turned into a liquid, and that liquid took up less space, so
Think
the balloon
about
inflated.
in the wintertime, if you're standing outside and you're really, really cold, do you spread out and get really big, or do you get really small and warm up like this? You get really small, right?
I go inside under an electric blanket.
Well, that's true, but they're all doing this over here, David. So you see, so I think they get smaller. So cold things get smaller.
Yeah, they get. Oh, we have a question.
Oh, we have a question from Facebook.
Yes.
Can I try this at home?
Who asked that? Anna? No. No, we are very well trained on this, right, David?
Well, that's true.
So a lot of this can be very dangerous because it does deal with expanding pressure and it deals with very, very, very cold temperatures, right?
That's right, that's right. With some of these science experiments that we do at the Science Center, you can certainly try them at home. We'll be posting more of those throughout our summer. You can check those out. But for something like liquid nitrogen, it takes an extra amount of training. So a great question. If you want to come enjoy liquid nitrogen, come see us at the Science Center.
Science Center. We have another question. question.
Can you do the same stuff with dry ice from John?
Ooh, great question, John. You want to take this one, David?
Well, sure. Some of this can be achieved in a similar way. However, dry ice is a little bit warmer than liquid nitrogen. Charlie, what's 108? 109.
109.
109 degrees below 0 Fahrenheit. So you think about that more than 200 degree temperature difference. So some of the effects will be similar. But actually, that gives us an idea for maybe another show in the future. Maybe we'll bring some dry ice out and show you what to do, as that's a little more.
I have another one.
From Taylor's dad, are you afraid to work with liquid nitrogen?
Oh, hi, Dad. I'm not. I love the liquid nitrogen. When we started, I was a little hesitant because I know how dangerous it can be.
Yep, it is terrifying.
It can be terrifying.
It can be terrifying.
But if you are careful, if you take the extra safety precautions, we are a-okay. Good question, Dad.
Dad.
Love you, Dad.
Okay with that.
Good. Can we take another question here in this room? Taylor, you want to grab
Let's do it. We have our volunteer, Jessica. Jessica, what's your question?
Like a regular oval shape. Why was it shaped abnormally when you went to blow it up?
That's a great question. Why was the balloon shaped different?
Okay. So if you look at the shape of the balloon, it was coming differently. Well, the liquid nitrogen inside the balloon cools down the exterior of the balloon. It changes the characteristics of the balloon itself. So certain parts were warmer and they could expand as usual, but the colder portions stayed nice and tight. So that's what gave us that oblong shape. You would see the same effect with the inflating balloon that we did at the very beginning for a very similar reason.
Right.
We have another question online.
Not a question, but a comment.
Comments?
Sure.
Guy named Dean, I believe is how you say it.
Okay.
It says the lead guy has a great mustache.
Oh, thank you. I like my mustache.
Plug it.
It is pretty great. I'm in a show, just in case you guys are interested. It's a show all about history at the Encore Musical Theater. Look it up, the Encore Musical Theater, re.org. Yeah, check that out. We run all weekend.
Questions from the audience.
Where do we learn? Well, a lot of that's we learn in-house how to do. However, it's becoming more of a trend to have restaurants that cook with liquid nitrogen.
I have a question. Who's ever had Dippin' Dots ice cream before? You've eaten liquid nitrogen ice cream.
The ice cream of the future.
Yep, that's very true.
Thank you, Dippin' Dots, for your sponsorship. So a very, very good question. We learn in-house, but other places use it in their cooking as well. I thought I saw a question over here. Yeah, right over here. What's your question?
No, you have a hat. You change your mind? I saw somebody else. You have a question. What's your question, sir?
How did you pop that balloon?
How did we pop that balloon? That's a really good question.
So, you want to take this?
Sure, David, yeah. So, when we put the liquid nitrogen inside the balloon, that gas is getting warmer. Remember how we launched the rocket because there was too much gas inside the rocket? The same thing happened, only that time we didn't give it anywhere to go.
Yeah.
So it was forced to come out and explode. Do you have a follow-up question? Sure thing. What's up?
I broke a stick one time.
Did you really?
Yeah, I used my knees and I just broke it in half.
Oh, so you used too much force. That's
Yeah,
kind of
exactly.
similar.
It's the same idea. Do we have another
You
online?
have another one?
A question from Scott.
Hey, Scott.
Scott?
What is your favorite element other than nitrogen?
Ooh, that's a good question.
Favorite element.
I like gold.
Mine is surprise. The element of surprise. That is my favorite.
It's not on there.
It's not on
The
it.
lower one. It's right there.
Oh!
Here it is.
Surprise! I don't know. I like
I also like Krypton.
all the good ones.
Because I like Superman.
Yeah, that's pretty good. I like badmonium. That's a good element. Is that one of them?
Yeah.
Did I make it up?
Let's get another question.
Okay. So yeah, you're right here in the Great Wolf Kids. How did we make the cloud? So we made this cloud the same way that nature makes a cloud, right? Taylor?
That's right. So up in the sky, clouds happen when water vapor gets really, really cold. So again, remember how we were talking about how cold things get close together? So all the molecules from that water and the water vapor got really close and got a little bit thicker. And that's why it got so big.
Yeah. Danielle, do we have anybody else questions online? Well, let's take one more in-house, okay?
That's a good idea.
And let's go right here, right in the center. Could liquid nitrogen stop a fire? That is a great question.
That's a wonderful question.
Now, here is how, because fire needs three things to work, Taylor, right?
That's
What are those
Yep,
three
it
things?
needs fuel, heat, and oxygen.
And oxygen.
Yep.
Now, the reason that liquid nitrogen could help put out a fire is because the oxygen would be displaced
That's right.
by the nitrogen expanding into a gas. So in theory, we could use it. It would still be boiling, but yeah, if we got rid of the oxygen, the fire would go out. Great
And
question.
actually, a fun fact, if you come to the Michigan Science Center this weekend for a Ford Family Free Day,
Yes.
we are actually, not me personally, but my colleagues will be performing a fire show
Now-
called Kaboom Street.
Taylor, which day is free this weekend?
Oh, actually, all 3 days are free. So, Saturday, Sunday, and Monday the 4th.
And Monday the 4th?
Yep.
I think Monday the 4th probably pretty
Probably
packed.
because you have to register online. So make sure you go to mysci.com.
Check out our website
Right.
for that. And yeah, unfortunately, we have run out of time. Now, if
Yeah.
you're at home, feel free to leave
Do we
questions
have
on
one
the
more
Michigan
question?
Science.
We have one more question.
One more. I was so beautifully wrapping it up. Okay, no, go right ahead.
That's a great question. Where does liquid nitrogen actually come from?
Well, let's see. I mean, on Earth, we experience nitrogen mostly as a gas. Charlie, could we find it anywhere? Liquid nitrogen on the planet? No.
So it's not naturally occurring, right? So it has to be...
Not on Earth. We have
it's
to
a
manufacture it. The temperature is too low, and the requirements of keeping it under pressure are too high in order to maintain that. Yeah, great question. Although if you become an astronaut, explore space, maybe we can find some out there.
Yeah.
Now, again, if you have questions on Facebook, feel free to leave them on the Michigan Science Center site. We'd be happy to post some answers later today. If you have questions out here, we will be down here. Remember, my name is David.
My name is Taylor.
We hope you have a great rest of your day.